First I just want to thank everybody for showing up at almost the last session of the conference. Appreciate it. So today we're going to talk about NATS, and so my name is Kevin Hoffman, Director of Cloud Engineering at Synadia. I created a couple of open source projects, co-founded a WebAssembly platform as a service company, and just all around nerd. So that's pretty much all there is to me.
Underselling yourself, Kevin.
Yep.
Hello, everybody. My name is Byron Ruth. I'm the VP of Product and Engineering at Synadia. I've been a NATS project maintainer for a handful of years. I help part of the release team of the NATS server itself, so you might see my name pop up when we're doing releases on the NATS server. And then, fun fact, prior to joining Synadia, I was actually at a pediatric hospital building software for research for nearly 15 years. So, fun little tidbit. And just before we kind of kick things off, make sure everyone's paying attention, because you might be able to win this jacket if you can answer a question at the end of the talk. And then also, on your way out, once we're done, one of our colleagues, Nate, is going to take any little short, couple-minute interviews. If you have anything to share about your experience with NATS, that would be awesome, because we like collecting feedback and collecting stories. All right, so typically with these talks, this is a NATS maintainers track talk technically, so I wanted to not assume that everyone knows what NATS is, so I'm going to do a super fast walkthrough, try to build up the motivation of what NATS is, why NATS, those types of things.
Before we go that, just a quick show of hands, how many are actually familiar with NATS?
Yeah, good call.
Oh, excellent.
All right, so majority, that's cool. What about who's using NATS in production? All right, fewer, that's cool, that's good. We'll get more of that.
Yeah, got some work to do.
Got some work to do, yeah. All right, so, dramatic statement. So the reason this is up here, we're at KubeCon, and walking around, you see a lot of tech that is layering on abstractions. No diss on any technology here, but especially with Kubernetes, the rise of Kubernetes, there's a lot of layers and layers and layers upon Kubernetes as one example. It's not just about Kubernetes, but NATS originated back in 2010, and the times were simpler then. And being a simple messaging bus at the time, it has evolved quite a bit. It has a lot more capabilities, which we're going to dig into. And thank you. And so one of the observations over this time period is that as the industry and the complexity of what you can do keeps increasing, the sort of NATS-based philosophy has remained steady, and keeping simple things simple and not trying to add complexity where we don't need it. So if we sort of look at a modern OSS stack, these are some of the technologies you might see in an application architecture, system architecture. None of these are individually, they're all great technologies, and they're very popular. But it's one of those things that we step back and we're like, if I'm building a system that needs some of these, basic, let's say, messaging primitives or storage primitives or, routing, load balancing, you keep, combining all these things together, and you start gaining a lot of complexity out of that. So what's interesting about this is the fact that at the very lowest level, we argue that this complexity comes from a couple specific things. So a lot of the foundations when building applications is based on one-to-one communication. So we have direct IP, port, and DNS, and HTTP keeps. Thank you, Kevin. I'll pay attention to this. And
it's gone again.
Okay. I'll just have to wiggle it while I talk. That'll be fun. So it's like doing one of those, right? So the idea is that if you had a different foundation of how things can be connected, how things can communicate outside of just a one-to-one style model, you can actually get a lot of things for free. You get a lot of benefits. And people will say, yes, that's PubSub, end-to-end communication. So we'll get there in a second. The other observation was that, well, if we have this sort of core thing, maybe we don't need these load balancers. Maybe we can get by and have a technology that just kind of like does that for us. Another thing is just not necessarily observed at the time and when NATS was created, but certainly in this era where we have larger and larger scale deployments. Single region deployments is you know, that still suits a certain set of application, but more and more we want to go multi-region, multi-cloud, you know, distributed out to various edge endpoints and things like that. And then inherently, the more technologies you have to adopt, the more there is to learn, the more that you have to figure out the whole security layer over top, the authentication and authorization layer on top, and that's where a lot of this kind of complexity comes from. So, you know, we stepped back and I talked about a couple of these like end-to-end communication. So NATS has all of these things effectively, like there's some properties of NATS that have this baked in, and sort of as a result of that, as being a single, literally a single binary, single component that you actually have to use and operate and scale, it's much simpler to learn and to use and to leverage. And the security model is already baked in. Multi-tenancy is already baked in. You know, it's a really nice foundation to build upon. So, you know, as a one-liner, it focuses on connectivity and communications as its foundation. It has evolved beyond just the message bus. We do data streaming, and this is why teams love NATS. It sort of suits the developers, it suits the architects, it suits the operators. Operationally, it's very simple to manage, and if you look at something like, again, no diss on technologies, but you know, a large Kafka cluster or something like that, because people come to us all the time, they're like, I think this is getting a little too complex. Could NATS solve our problem? So we hear that a lot, and we say, yes, it is quite simpler. So operators really enjoy the technology. Architects, in terms of being able to build, you know, the size of cluster they need, the topology of cluster they need to suit their use case. And then developers, all of these basic primitives are built in, and you can just use a single client SDK to kind of get all this stuff out of the box, which is quite nice. So more concretely, just from a project standpoint, and that was a quick whirlwind, we want to get to the fun part. Again, it's a static Go binary. We support 4 different operating systems across 7 different architectures, so you can kind of run NATS wherever you need to. And then there's 11 official client libraries across all your major programming languages. The community's awesome. So if you're already not on the Slack or you're not, you know, subscribed to the newsletter, all those links will be at the end to look at. Final quick part of this segment. I'm not going to read this off, but we did a couple of things this year in 2024 since the last KubeCon North America, and then we have a NATS 2.10 release that's coming up. We're shooting for the end of the year. I know probably many of you who've been following along have been waiting very, very patiently, but we have some really good stuff that's coming.
All right. So apparently I get to do the fun stuff. So those of you, most of you said you were familiar with NATS. Has anybody actually heard of NEX? All right, so we got one person. Early candidate for the shirt.
Yeah.
So one of the things that I love doing is using technologies in a way that they haven't been used before. And one of the things that I started playing with NEX was, what if I can use NATS as the target for distributed computing? So if if I'm building my applications on top of NATS, then I already have this pre-existing NATS infrastructure. I've got NATS servers, I've got leaf nodes, I've got clusters. Why don't I just reuse that or harness all of that infrastructure and use it to deploy applications? So that's essentially what NEX is, the NATS execution engine. So I can store my executables pretty much anywhere, Jetstream, on disk, pull them from OCI repositories or registries, and I can deploy them anywhere I have NATS connectivity.
Good.
Yeah. Sorry, I wasn't wiggling enough. And again, same principle as NATS. There's just a single next binary. So again, the short version is anywhere I have NATS running, I can now deploy workloads. So one of the big things that I'm trying to, or that we're trying to solve with NEX and NATS in general is the traditional disparity between development and production. Most of the time, what we end up with is sort of a faith-based model where I build it locally and I hope it works in production, and I find out whether it's going to work in production after I deploy, and I've caused a big production outage. Another option is I can essentially put all of production on my laptop, and sometimes that's useful, but it's typically pretty hard to just cram the entire internet into my laptop. And then we can, my wiggling game is off. So the next thing we can do is do simulations where I have a bunch of stuff on my laptop that pretends to be production. And it usually seems like a good idea to start with, but then what I end up doing is testing the mocks and testing the simulators, and I really don't have a good way of proving that what I'm simulating on my laptop is going to behave the same way as it does in production. Again, point-to-point communications is usually very difficult to deal with because, again, many of those points that I need to communicate with aren't running on my laptop. And I need service discovery, client-side load balancing libraries. You get the idea. We're just adding more complexity. And again, we spend most of the time debugging the environment and not the app. And so with a NATS-based development workflow, if I make some key decisions and follow a certain set of patterns, then I can build locally, run it locally, and know that it's going to work in production. Because, again, my app is just depending on NATS primitives, and those primitives work the same way on my laptop as they do in a 3-region supercluster. If I rely on NATS to communicate with external services, then when I do mock that communication, then I have a higher guarantee that that's actually going to behave the same way as it does in production, because I'm not messing with HTTP and routers and gateways and firewalls and any of that. It's just a NATS subject. If I have at least in my experience, 90% of my data storage needs can be met with NATS primitives like jetstream streams, key value buckets, and object stores. And sort of the big thing, one of my pet peeves is, and we're probably pretty familiar with this at a conference on Kubernetes, where the technology is driving our architecture, not the other way around. And I should be able to sit down and design the application that I want and build that application, rather than having, this arbitrary combination of 30 vendor products dictate to me how I have to build my app. So one of the other things that NEX has is this concept called host services. And again, it just sort of builds on the idea that we're already building applications that use NATS. So if I deploy a JavaScript function to NATS, then there's a suite of host services that gives me access to NATS primitives without me having to do anything. I don't have to make a network connection, and in the case of JavaScript, it's physically impossible. I don't have to set connection strings. I don't have to worry about secrets. I don't have to worry about any of the things that normally slow me down when I'm trying to develop, when I'm in my development loop. And I'm not sure if this was, whoops. Apparently I can't highlight. I can wiggle though, so I guess that's all right. For JavaScript, we just have this thing where we're injecting an object called host services. And so I can do host services.kv, host services.obj, .messaging. And so all of the things that I can do with NATS, I can do inside my JavaScript function. And there's an example of what the command line looks like to run a JavaScript function inside NATS. So I have a small application that I want to show that will highlight sort of the general development flow and what it looks like to start applications using NEX. And just as a note is that the version of NEX that I'm going to use for the demo is essentially a future branch. So within the next few weeks or so, you will start seeing release candidates come out of that, and that should eventually make its way to NEX 1.0. We'll be able to deploy services, and by service, I mean anything that you can run, whether it's a native binary or a Docker image. We can deploy those from OCI registries, and one of the applications that I'm running is going to use a NATS micro service. Who here is familiar with the NATS micro framework and standards? And okay, so short version of that is there's a specific set of subjects and standards that if you follow it, then you get service discovery essentially for free. And it comes with most of the client SDKs, I think. So, Go, Rust, all of those, they all support the microservices structure out of the box. So let's see if I can do a demo here.
Looks pretty good.
That's legible?
Good, legible.
All right, cool. So the first thing I want to do is I'm going to start a next node. And really? So I'm going to start a next node. And a next node is, like I said, just a single process. And as long as I have a connection to NATS, I can start it. So whether I'm running this in the cloud to host cloud-based workloads, or whether I'm running it on a Raspberry Pi to run edge-based workloads, it's all still the same stuff. So that's it. I now essentially have an empty host that I can use to deploy workloads into. And so I have this command called workload run, where I give it the name of the workload, and I tell it where I want the workload to run. And in this case, the node ID should look sort of familiar if you've been operating NATS for a while. This is just a node key for NEX. If you start more than one NEX node, they automatically form a cluster of nodes, and you can stitch together your compute infrastructure the same way you can your NATS messaging infrastructure. Another interesting thing about this is that what I'm going to run is actually in the GitHub artifact registry. We'll see if the hotel wire, all right, Wi-Fi seems to have worked. So I've just got a little log message here that says I've spawned a process. So whatever binary was sitting inside that image is now running, and I can get a list of the next nodes that are running. Really? I mean,
There you go.
come on. Got me a break here. Okay, so this is the list of nodes that are running. The important thing to note here is that it's got one workload running. And if I check the info on this one node, you'll see that I have counter running as a workload and when I started it. And you'll also see that I have a microservice running. The microservice is running because it's inside the workload that I just deployed. So, I can do NATS micro info. And so now here are the endpoints on my, come on.
It'll come back.
All right. It's all just one big conspiracy against me. So I have two endpoints, count and stepper. Basically, the workload that I deployed is just constantly counting up. Not all that useful a functionality, but at least what it does show is it gives me a way to show you that I have a workload that's running in the background doing a long-running process. So it's counted up to 101. Now it's up to 103. Pretty soon we'll have our own blockchain. And I can change the amount that it steps up by doing so now it's counting up by 2. I should be able to sell this to a VC for a couple million easy. And one other thing I wanted to show is inside that same workload, I have a web server that's running that's showing me the counter and the current value of stepper, so I can drop it down. And, so essentially I've got my fully running, fully functional, highly profitable web application all deployed on NATS. And, if I see that I've got, too many customers to handle, which is pretty obvious from this app. If I've got too many customers to handle, then I can just go back into the next command line and add more instances of it. And if I want to add another instance to US East, US West, 3 different clouds, it doesn't matter. So I can essentially, because I'm sitting on top of NATS, I can deploy my compute to any cloud I want to, including on-prem, out at, remote devices, IoT devices in the field, fleets. All of that stuff is now just easily deployable because I've built NEX on top of NATS. All right, so let's see if I can find my way back to the slides. Make sure I'm getting the wiggle in. So there's a couple of different ways that you can use NEX. The one that I just showed was I've just got an application and I'm going to use NEX to deploy it. You can also use NEX as your own platform. Everything that I do to remotely control workloads is available as a client SDK. So I can write code that starts workloads automatically. And so we've got an application called Poker, or All-in NATS Poker. And it is a suite of microservices, and there's a Go binary for the web server. And what's interesting here is that as load grows and more customers come to play yet another highly profitable game, we can use NEX to dynamically start more poker tables. So each poker table is essentially one long-running service that's playing out the game state in memory. And for the gamers here, this is essentially the lobby and shard pattern. But again, everything here is NATS-based. All of the persisted data is stored in key value stores. All of the messaging is done over NATS, and all of the streams, again, just Jetstream. So we have a user service, a bank service, a lobby service, the web application itself, which is currently publicly deployed. And when we need more poker tables, we can just spin them up with an X command. So this is roughly what this architecture looks like. So we have our cluster of NEX nodes as the game maintainers. And so this has all of our services in it, including a tables service, which is responsible for spawning individual workloads that manage poker tables. So let's see if I can find poker here. All right, so this is, yeah, I can't really, can I make that bigger? Yes, I can. Okay. So in order to keep our costs down, I removed buttons that would make it so that you could just dynamically spawn an infinite number of poker tables. But there's one poker table that's currently running. And if I go look at that table, again, this is the administrator view, so I don't have to, I'm not looking at what the end user would see. You can see how inside this process, there's a number of different players, and we're maintaining their stack, whatever that is. Obviously, I'm a champion poker player. And however much money they have, and we're dealing cards and so on. So it's essentially running its own poker game inside that table. And when this table fills up, and we reach the maximum number of players of 9, we could write code that just sees that event and creates a new table. And then when that game is done, or when enough players leave, we can just shut down the table process. And so obviously the goal here isn't to teach everybody how to make a poker game. The goal is that NEX is not only a vehicle for you to deploy your own applications wherever you want to deploy them, but it can also be used as a platform to build applications that use the dynamic workload scheduling as a feature for your own app.
Cool. Thank you, Kevin.
Yep. So now that the fun stuff is over.
Back to me. All right, so just to kind of wrap this up, bringing it all together. So going back to the first handful of slides and making that claim that rethinking application design, building upon connectivity at the bottom, and then building primitives on top. And NEX is sort of the next iteration of this, introducing workloads. So again, NATS has connectivity, the messaging, the clustering, arbitrary topologies. With the data side, we have streams, they're persistent. We have KV abstractions, object store abstractions on top. And now we are going into the workload part of the stack. And now you can build full-blown nothing but NATS applications, basically with NATS and NEX together. And I think an important thing there is that the NEX nodes, as Kevin said, they can cluster, they can kind of independently scale. If you only need a smaller NATS cluster, you can have many, many more NEX nodes if you need to. So that's why it's sort of a deliberate decision to sort of separate those two things.
Yeah, on that point too, I think it's important to mention that, and I kind of alluded to it, is that the NEX nodes don't need to be in the exact same physical location as a NAT server. All they need is connectivity to a NAT server. So, one of the really fun architectures that I've been playing with is, a physical device that's managed by a Raspberry Pi. There's a leaf node on the Raspberry Pi, and there's 2 or 3 NEX nodes inside that device talking to the leaf node, and the leaf node talks back to Synadia Cloud. So, again, you're only limited by your imagination and, well, I guess money, right?
Your imagination, yeah. Well, here's a couple real-world imagined things. These are just rough diagrams from some of the customers at Synadia. Obviously, no disclosure of names or anything like that, but these are actually real architecture diagrams. At a very high level, but the point is, and this goes back to beyond cloud native. So cloud services, cloud providers, they're great. They're differentiated, use them, leverage them, but take a step back and say, should I be completely all in on one cloud provider, or do I need to go across clouds? Are there multi-region sufficient services out there? And we found with our customers who are, some of which are very large scale, lovely. Wiggle, wiggle. You can get into some really interesting architectures. And in this particular one, we have a customer that has to go across all 3 major cloud providers for regulatory reasons and have data shared in all 3 cloud providers. And then they also have their own physical data center. So they can cluster a bunch of NAT servers together as it forms a supercluster. And then they can be able to store the data locally as they need to in those respective areas. And then introducing next, being able to, again, it's not released yet, but logically you can think of, now I can actually deploy workloads right alongside it. I don't have to introduce all this additional infrastructure and other compute abstractions. Here's another one that's more of a retail site device edge. This is more of like a retail store type of model. Same basic pattern. It's just a different topology. It's a different flow of things, but it's the same. It's just beyond the cloud. Like you need to be in a point of sale system. NATS can sit there too, and we have customers doing that. Sorry. And then finally, all the rage, AI at the edge. We have customers building AI at the edge, whole companies based on NATS. Sorry.
It's really the productivity monitor,
really
making sure we're doing
today.
work.
Yeah. So, between data collection at the edge, you move that data all the way up into the cloud where you have very beefy machines and you can do the training, you can do all that stuff. You create the model, you can push down the model down to a local object store at the edge and do local inferencing and use a workload there and a service running. So we have people today doing that, and it's all off the back of NATS. So it's sort of just to show what the power of this combination actually is. And this is these slides will be up on the sketch.com, so I know I'm rushing through a couple of these things. But you can kind of see the layers that we have that are all stacked, and just even though we have our Synadia logo, this is all open source. NATS and Next are open source, just to be clear, okay? All right, we have a few minutes for questions, but here's some resources, and that's the feedback QR code if you have any. We probably have time for maybe one question, and then I'm going to ask one question to see if we can give away this jacket, and then if anyone who has questions afterwards, you can come up to Kevin and I.
Thanks.
Yes. Hi, my question is regarding the actual infrastructure, because the way I understood the NATS is basically kind of a sidecar, meaning I have a node, and then I have a sidecar of NATS where my applications talk to the NAT and it distribute how it's supposed to be distributed. But then, how will I orchestrate the actual physical nodes or the actual physical stuff? Like, what kind of solution do you suggest?
Yeah, no, great question. So NATS doesn't need. It's kind of two separate parts there. So you have a NAT like a single NAT server. You have your client application that uses one of the NATS SDKs. You can just build your application using the NATS SDK. That application connects directly into NATS. It could be a single server, a whole cluster, a whole supercluster, whatever, it doesn't matter. And then all of the messaging happens just over that. It's not a traditional sidecar like you would have like a Envoy proxy in an Istio context or something like that. There's actually no need for that. And then similarly, as Kevin said with the next side, that itself, that node is also connected into NATS, and that's how it can, over kind of the control, the management plane, you can schedule the workload on that next node that's actually connected in. So if that's helpful. So you really can have like bare hardware. You spin up a NAT server, you spin up a next node, they can be on separate places, separate hardware. And as long as they're connected in, then everything kind of just works.
Yeah, typically if you're deciding to run NATS physically close to an application, it's not because you're being forced into a sidecar model. It's usually something where you need to localize traffic, or you're trying to optimize latency between two applications, that sort of thing.
Cool. Just mindful of time. Again, if you have any more questions, you can come up to us afterwards. So
get to the good stuff.
Get to the good stuff. So you can keep it, you can auction it, you can do whatever you want, whoever gets it. This is one of our colleagues, David G. If you saw him walking around the conference floor, he actually made this. So,
We should have made people try and crash poker, and whoever crashed poker got the shirt.
so question. Let's see if anyone gets this. What was the programming language that NATS was originally written in?
Go.
So you said Go? Ruby. It was originally written in Ruby. Nice job. It came out of Cloud Foundry, and Cloud Foundry was written in Ruby, and then it was rewritten in Go a couple of years later. Congratulations.
Thank you so much.
Wear it with pride.
Yes, wear it with pride. At least take a picture, tweet it out. That'll be fun. All right, thanks everyone. And again, we'll be around for a few minutes. We can chat, but thanks so much for your time.
Thanks.